Welcome to our last lesson on hypothesis testing for two samples. Today, we're going to be testing proportions. It's really fun, always interesting. Here we go. We can use a z-test to compare two population proportions, P1 and P2, using a sample proportion from each population. Both populations must be randomly selected. The samples must be independent. The samples must be large enough to use the normal sampling distribution. A 2017 study showed that 54% of males watched Star Wars Episode 1, The Phantom Menace, and 52% watched Star Wars Episode 2, Attack of the Clones. 2,200 males were surveyed after each movie. At alpha equals 0.10, test the claim that there is a difference between the proportion of males who watched Episode 1 and the proportion of males who watched Episode 2. We're going to use p-values. I like to organize my information over at the right before I dive into the problem. So I know that after each movie, 2,200 males were surveyed. So those are my sample sizes for both. 54% of males watched Episode 1. Well, 54% of 2,200 is 1,188. 52% of 2,200, 1,144. My hypotheses are going to look like this. The null is that the proportions are equal. The alternate is that the proportions are not equal. Alpha equals 0.10. We're doing a two-tailed z-distribution test. So if p is less than 0.10, we're going to reject the null. If p is greater than or equal to 0.10, we'll fail to reject the null. Pull up your calculator, your TI 83 or 84, go to Stat Tests, and down to T Prop Z-Test. In here, you get to summarize all your data, x1, n1, x2, n2, what kind of test you're using. Go down to Calculate and hit Enter. Here's all the information you need. We've got a p-value of 0.18. 0.18 is greater than 0.10, so we'll fail to reject the null, which means it is likely that the proportion of males who watched Episode 1 is the same as those who watched Episode 2. Let's try another one. As of 2019, 35% of males and 37% of females in the U.S. had completed 4 years of college or more. If 800 males were surveyed and 500 females were surveyed, can the study claim that the proportion of females with at least 4 years of college is more than the proportion of males with at least 4 years of college? We're going to test this at the 0.01 significance level using p-values. Again, over at the right, let's put down what we know. We know that 800 males were surveyed, 500 females were surveyed, 35% of males, 37% of females. That translates to 280 males, 185 females. So we're testing the claim that the proportion of females is more than the proportion of males. Our alternate then would look like this. P1 is less than P2, and our null is the opposite. P1 is greater than or equal to P2. Alpha equals 0.01. We've got a z-distribution left-tailed test. So if p is less than 0.01, we'll reject the null. If p is greater than or equal to 0.01, we'll fail to reject the null. Again, go to Stat Tests, to Prop Z-Test, and plug in what we know. 280 out of 800, 185 out of 500. We're doing a left-tailed test. Hit Calculate, and we get a p-value of 0.232. 0.232 is greater than 0.01. We'll fail to reject the null, which means there's not enough evidence to claim that more females have at least 4 years of college or more. There we go, the last lesson in hypothesis testing. Today we looked at studying two different proportions, comparing them. Hope you enjoyed it. Good luck. Thanks for being here.